Somewhere, deep underground in super-secret laboratories, scientists are trying to create a black hole. It looks like the latest experiment was a success. The black hole hovers above the desk for a moment, but then, in a split second, it swallows it whole. Uh-oh. After its meal, the black hole grows until it is out of control. Microscopes and test tubes fly into the dark void. Soon everything in the room has been consumed. Each time it eats, it grows bigger and bigger and attracts even larger objects. On the surface, people go about their day as usual. Some joggers stop their run when they see a giant black sphere growing in the distance. Houses are torn from their foundations, and cars fly through the air towards the black abyss. In just a few minutes, the black hole has enveloped our entire planet. Then it grows big enough to consume the Moon and Mars. The black hole is now heavier than anything in our solar system. All of the planets begin to circle it before becoming food for the monster. Finally, even the sun is extinguished in the belly of the beast. Well, that was pretty bleak. Don't worry, this isn't how the scenario would play out in real life. Our scientists may actually be capable of creating a black hole, but it's far safer than this. The effort to make a black hole is led by the scientists working in Geneva on something called the Large Hadron Collider. This machine basically makes particles move at high speeds until they collide. When this happens, they release a lot of energy and create a lot of interesting effects. Scientists think that energy released by these collisions might be enough to create a black hole. Some people were so worried by this that they even tried to ban the construction of the Large Hadron Collider. Luckily, if a black hole did appear, it would be so small that it wouldn't be able to do anything. Black holes actually produce a lot of energy and release it, often as heat like a furnace. That means that they will fade away when they run out of fuel. If one appeared in the experiment, it would instantly burn out and disappear in a billionth of a second. Even if a stable microscopic black hole was created, it would grow so slowly that nothing would happen. Assuming that it survived long enough to absorb the tiny particles around it, a black hole of this size would take about 500 billion years to gain a pound of weight. Black holes could actually be really useful. One with the mass of Mount Everest would emit enough energy to completely power humanity. Even better, black holes are so dense that the one this big would only take up a tiny bit of space. We couldn't create anything as enormous as the naturally occurring black holes, though. Some can weigh hundreds of thousands of times as much as our Sun. Recently, scientists have observed a real black hole feast. The sight of a black hole tearing an enormous star apart is one of the most mesmerizing sights in the universe. Heavier and more destructive than anything else in existence, the black hole is both amazing and terrifying. And black holes aren't actually black at all. They're so massive that even light can't escape their pull, meaning that they're actually invisible. Scientists can only find them with special instruments. Most natural black holes are born as stars reach the end of their lifespan. You can picture healthy stars as giant furnaces that burn hydrogen and give off unbelievable amounts of energy. Every second, stars like our Sun produce more energy than humanity has ever produced, which pushes outwards and makes it want to expand. This is what eventually finds its way to Earth as the heat that birthed life on our planet. The only thing stopping this expansion is gravity, a force that basically just pulls objects toward something heavy. Most people know gravity is something that keeps us planted to the ground and stops us from flying off into space. The force of gravity of a star is so strong on stars that it makes them want to implode in on themselves. So, when a star is healthy, the force of gravity pushes inwards, and the energy it releases tries to inflate it like a balloon. These forces mostly cancel each other out and stop it from doing much at all. When a star burns through its fuel, though, nothing is pushing outwards to stop it from collapsing in on itself. Some really big stars make so much energy that they gradually expand into something called a red giant. When they run out of fuel, they cool, and gravity pushes the enormous object into a tiny space. Scientists use our sun to measure how big things in space are. Our sun weighs 1 solar mass. If a light star, like our sun, implodes, not much happens, which is lucky if you've ever worried about being swallowed up into a black hole. If a red giant around 10 solar masses implodes, though, some incredible things can happen. The collapse of one of these is so intense that it explodes into a supernova, releasing a light as bright as the entire galaxy. Stars that are massive enough to produce supernovas sometimes become black holes. Their weight causes gravity to push down and compact them until they collapse into a black hole in less than a second. The inside of a black hole is mysterious and unexplored, for obvious reasons. One thing we do know is that they're so massive that they can even distort time. 1 second near the black disk can be equal to weeks or even months on Earth, depending on its size. In 2019, scientists watched a black hole devour a star the size of our Sun. Even though it was 860,000 miles wide, the star was completely trapped in the black hole's gravitational field. For a while, they danced around each other, gradually coming closer and closer. Eventually, though, the star was extinguished in the invisible mouth of the black hole. The black hole sometimes releases beams of energy into space. Sizzling plasma flies out at 6,200 miles per second as the black hole finishes destroying the star. About half of the star's mass is consumed, while the rest is ejected into space. Incredibly, these insatiable titans even consume other black holes when they get big enough. The collision of 2 black holes was recently witnessed by scientists, when one, weighing in at 85 solar masses, met another that was 66 solar masses. When black holes interact, the bigger one always swallows the smaller, adding even more mass to itself. The resulting black hole here reached 142 solar masses big. It's hard to believe, but this is still very small for a black hole. It will continue to consume everything around it and might even reach the size of a supermassive black hole at some point. These are unbelievably big and destructive. Our entire galaxy, the Milky Way, rotates around the gravitational field of one of these supermassive black holes. This monster weighs around 4 million solar masses, or more than 1 trillion times our planet. And that isn't even the biggest they get. It's also theorized that black holes can be made without a dramatic explosion. Big gas clouds that weigh hundreds of thousands of solar masses could condense under the force of their gravity to make a star. This object would already be so heavy that it would continue to compact until it became a black hole, skipping the supernova stage. Supermassive black holes are so far away and hard to observe that scientists doesn't have a full understanding of them yet. We don't know much about what happens inside a black hole, leading to a lot of speculation. For decades, people have theorized about how we could use black holes. Knowing that black holes distort time means that someone could use it to travel to the future with the right technology. If it was possible to build a ship strong enough to withstand the powerful gravitational fields, it would be simple. All they would need to do is decide how far they want to go and fly around the outside of the black hole. In the few minutes or hours they spent near the time warp, years could have passed back on Earth. They could be thousands of years old without having aged at all physically. Wow, that's officially a mind-blower.
Did you know that the elusive Hawking radiation, theorized by Stephen Hawking, has never been seen? Until now, scientists have recreated a DIY black hole on Earth, and the results are astounding. Join us as we unravel the secrets of this cosmic phenomenon. Look at this funky orange donut. It's one of the few photos of a black hole that we humans possess. The first version of this image was released in 2019, and it took scientists some time to tweak it so it looks a bit sharper. Now, it has a dark center and an orange rim. We don't exactly know what black holes look like. They're something we can't directly observe, but we can infer their presence and study them. Sorta. Black holes are like the ultimate vacuum cleaners of the universe, and even if someone ventured into the great unknown to study them, we would never know the result. The scientists just wouldn't make it back. People have long believed that the only thing black holes can do is to devour. But back in 1974, Stephen Hawking said that black holes aren't just empty voids sucking up everything in their path. Black holes can shoot out some light of their own. This phenomenon was later named Hawking radiation. But nobody had ever actually seen this mysterious radiation in real life, so it remained a theory. It was impossible to prove it by looking through a telescope. The simplest way to see and study a black hole is to replicate it in a lab and look at it right there. You may instantly think of the Large Hadron Collider, that famous particle accelerator. Technically, if we accelerate the particles and smash them into each other, we might have a black hole in the end. Currently, the LHC is nowhere near reaching the required energy to create an actual black hole. But scientists found a different way to simulate black holes on Earth. Their goal was to understand how we see the Hawking radiation waves fall in and come out. They realized those waves are pretty slight. Plus, it's virtually impossible to see them from a real black hole. The thing is, Hawking radiation might be simply overpowered by other radiation sources. But it's impossible to avoid these complications using a domesticated man-made black hole. It may sound like they aim to create microcosmos in a lab, but of course, the replica was not intended to be the same as the original black hole. For example, the DIY black hole lacks a signature spaghettification feature. Also, while real black holes are all about light waves, scientists on Earth had to make do with sound waves. In space, nothing, not even light, can escape it if it crosses the event horizon. Things work pretty much the same with the DIY black hole, but in this case, no sonic vibrations can escape once they cross the boundary. This black hole analog was more like a tube rather than those swirling things you see in NASA pics. The scientists were just curious to see if one of those quantum entangled particles that got close to the event horizon would escape as Hawking predicted. You see, quantum entanglement means that two particles act the same, no matter where they are in time and space. Creating a black hole from scratch seems to be a pretty complicated adventure. It might seem that such an experiment needs some intricate ingredients, like California and other fancy recently discovered elements chilling at the very end of the periodic table. But the black hole the researchers created in the lab was made of rubidium gas. Rubidium gas is faster than sound itself. It's so quick that it puts a stop to any sound waves trying to break free, just like how a black hole's crazy gravity does in space. While experimenting, scientists used lasers to hold atoms in place and make them act like one big atom. With another laser beam, they made this gas flow like a waterfall, creating a sort of event horizon. Rubidium is a pretty humble element number from the periodic table. It's number 37, and you can find it between krypton and strontium. Even though rubidium is the 16th most abundant element in the Earth's crust, it's still relatively rare. You probably even saw it with your eyes. Rubidium compounds are sometimes used in fireworks to give them a red-violet color. It's classified as an alkali metal, which means it can be dissolved in water, just like instant coffee. Also, it has a relatively low melting point, just slightly higher than body temperature. Collectively, all the atoms in a DIY black hole weigh about 1,000th of a single bacterium. It's made up of about 8,000 rubidium gas atoms and is only about 0.1 millimeters long. A grain of sugar, for instance, has at least 1 billion of atoms. Just so you know, rubidium costs about $36 per gram, so the raw material for this DIY project didn't cost a pretty penny. The whole experiment was constantly recorded on camera. Because the camera can instantly destroy the analog black hole when capturing it, scientists had to keep recreating the analog entity over and over again. They did that experiment 97,000 times. That's over 124 days of non-stop work. It paid off. The photos proved that Hawking radiation always stays the same. The team had to gather a ton of data to see how these sound waves behave together. And those waves did the same thing every single time, just like Hawking said. So, this experiment proved him right. But here's the thing. Until we can figure out a way to study black holes in space using a super advanced telescope that we can't even imagine yet, We'll have to rely on theoretical studies like Hawking's to determine if this happens in real black holes. Okay, you're not a scientist, but you still want to create a black hole replica. No problem. You're going to need some stretchy fabric. A t-shirt with Lycra will do, an apple, and 2 ping pong balls. Make sure to invite 2 friends, as you won't perform it alone. Put a ping pong ball somewhere on the fabric and just watch what happens. Now, roll it across the fabric and check out how it moves. Make sure those volunteers of yours pull the fabric tight enough so there are no wrinkles or bumps. Smooth it out as much as possible. Now take that ping pong ball and place it near the edge of the fabric. Let it go and see what goes down. If you lay the fabric flat and put a ball on it, it stays put. But if you roll it across the fabric, it goes in a straight line. The fabric represents space-time. When there's no big mass on the fabric, it doesn't curve at all. That's why the ball can just chill or move straight when you roll it. It's like how light travels through space when there are no black holes around. But now, let's say you plop an apple in the middle of the fabric. That causes the fabric to curve downward. Just like a big mass, like a planet, star, or black hole curves space-time, creating a gravity well. Now, it's almost impossible to keep the ping pong ball still. It always rolls towards the middle, and when you try to roll it in a straight line, it follows a curved path. As long as it doesn't get too close to the middle, you could probably still roll it from one end of the fabric to the other. Kinda like how light curves when it passes near a black hole but doesn't go inside the event horizon. But if it gets too close to the center, the ball gets sucked in and can't escape, just like light can't escape if it ends up inside a black hole's event horizon. Now, if you rolled 2 balls at once, you might have noticed that they didn't affect each other's movement as long as they didn't crash into each other. That's because the balls don't have enough mass to make any extra curves in the fabric. All the curving is caused by the much heavier apple in the middle. This shows why we only feel Earth's gravity pulling us down and not sideways by other things like people, cars, or buildings. Their gravity is way weaker compared to Earth's.
Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years, and it does show. See for yourself. Due to such a long isolation, the conditions inside the Mville Cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave, and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide, so not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. 2 miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the giant crystal cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super-tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7-feet-wide structures mystery circles. The enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long, long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths. There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andres Ruzo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andres Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. The water in it was indeed steaming hot. Its temperature was 186 degrees Fahrenheit, not boiling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind.